Hi everyone, welcome to Integral Calculus. Today we explore lesson 6.3, volumes of solid of revolution. Number one, volume using both methods. Here comes an example. 5 volume of solid generated by rotating the region bounded by the line y equals x, the curve y equals x squared in the first quadrant about the y-axis. Part A, using disk or washer method. Part B, using shell method. Okay, I have sketched out the bounded region to save time. Take a look at the reflection area. Okay, so if we do a rotation about the y-axis, then we're going to get this. Now to get a washer, take a sample stripe, horizontal sample stripe. So we're going to get the same thing right here. And then when we do the rotation, we're going to get an inner disc and an outer disc. This is, of course, a sample washer. Volume of the sample washer is base area multiplied to thickness. Now the base area is going to be pi r square minus pi r square. Thickness is, this is a horizontal stripe, so it's the small change in y. The bit radius is this. You have to go from right here to here. This is the bit radius here. So that is exactly x distance. And this x is, well, it's the from the parabola. X distance from the parabola. Look at the parabola. You can solve for x by square root both sides. So you will see that square root y equal x. Pi root y square. Yeah. Now let's take a look at the smaller radius. Smaller radius is this one. That is also an x distance, but x distance to the line y equals x. So that would be y pi y square dy. Simplify this and we have pi y minus y square dy. Ta-da! The volume is, well, sum them up from one intersection point to another. So from here to here, you got to find the intersection. Intersection points set the two x equal to each other. So that is the y equal root y. And so we see that y squared equal y squared minus y equal to 0. And then from there, you can factor of y minus 1 equal to 0. So we see that y equal to 0, y equal 1. Yay! This is 1 right here. Integral from 0 to 1. Pi y minus y square dy. Pi half of y square minus 1 over 3 y to the power 3. Evaluate from 0 to 1. And ta-da, we have pi 1/2 minus 1/3, which is pi/6. Wow, pretty cool. This is, of course, using the washer method. Now, let's take a look at how we use the shell method. So to use the shell method, we're gonna be using a vertical stripe. Before that, let me sketch out the reflection here. Let's take a look at a vertical stripe. We're gonna rotate the vertical stripe, and the rotation gonna get us a sample shell. Volume of the sample shell is circumference multiplied to height multiplied to thickness. Circumference is 2 pi r. The height is y. And then we can actually figure out this height right here. And then the thickness is the dx. The reason why the thickness is dx is because this is a vertical stripe. So the thickness is just a small change in x. Okay, let's take a look at the radius. Radius is from here to here. So that is just x distance. This x right here. 2 pi x. The height is this. This is the height right here. You can see that that is the difference between the y equal x and y equal x squared. The function above minus the function below. So that's x minus x squared. Dx, right? 2 pi x squared minus x to the 3. Dx. Ooh. We can figure out the intersection here. Because we're gonna be integrate from these two intersection points. Intersection points there. Set them equal to each other. X squared equal x. So x squared minus x equal to 0. X minus 1 equal to 0. So we have x equal to 0. X equal 1. Meaning that this point is 1. And thus the volume is the integral from 0 to 1 of a sample shell. Volume of a sample shell. 2 pi x squared minus x to the 3 dx. So I have 2 pi 1/3 x to the 3 minus 1/4 x to the 4th. Evaluate from 0 to 1. 2 pi 1/3 minus 1/4, which is 2 pi times 1/12. pi/6. Wow. It is the same answer as using the washer method. Ta-da! Pretty cool, huh? Okay, let's take a look at another example to see which method is best to use, because sometimes we can only use one method. Five volume of solid generated by rotating region bounded by x equal y minus 3 square and x equal 4 about the line y equal 1. One of them is a parabola, the other one is just a straight line. Now, x, y. And this parabola is at y equal 3. So here is number 3. And then you go this way. Yeah. Well, for x equal 4, you're gonna do an intersection right here. Ta -ta -ta. And thus the bounded region is this one. Well, let's take a look at the line y equal 1. We want to know what is this intersection here between here and here. We can set the x equal to each other and take a look. So intersection point y minus 3 square equal 4. So mean y square minus 6y plus 9 equal 4. So y square minus 6y plus 5 equal 4 equal to 0. And we can factor this out. Y minus 5, y minus 1 equal to 0. So ta-da, y equal 5, y equal 1. Ah, so I mean this is 1. And this number up here is 5. If you use a vertical stripe, and when you do the rotation, you're gonna get, of course, a washer. It is very difficult to figure out the radius because we would have to solve for y, the plus or minus, which make it a little difficult to do the computation. Okay, so scrap this. We're going to use the shell instead. So in order to get a shell, I'm going to draw a horizontal stripe. And then somewhere down here, we're going to get a matching horizontal stripe. Do the rotation, and we're going to get a sample shell. Volume is circumference. Multiply to height. Multiply to thickness. Circumference 2 pi r. The height, if you look up here, it's gonna be the difference between x equal 4 and the curve, right? X equal y minus 3 square. So that would be 4 minus y minus 3 square. When you look at the thickness, well, that is the horizontal stripe. So the thickness is small change in y dy. Next step is, let's take a look at the radius. The radius is this. This is the radius right here. And as you can see, the radius is Well, why? Because the -1. So this distance right here is the line y equal 1, right? So it is 1. From here to here is 1. That means this small distance is y minus 1. 2 pi y minus 1 multiply to four minus y square minus 6y plus 9 dy. Work out the algebra and we have 2 pi times minus y to the 3 plus 7y square minus 11y plus 5 dy. And with this, we have the volume of a sample shell. So we can figure out the volume of the solid of revolution by add up these sample shell from 1 to 5. Integral from 1 to 5. 2 pi minus y to the 3 plus 7y squared minus 11y plus 5 dy. 2 pi minus y 4 over 4 plus 7y3 over 3 minus 11y squared over 2 plus 5y. And we evaluate from 1 to 5. It's going to be a lot of fraction. If you work out the fraction, then you're going to see that the answer is going to be 2 pi 64 over 3, which give us 128 pi over 3. Oh, it is a good problem. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.